Hi everybody, if everyone you know has come. So, let's start. Hi, I'm Shravya. I'm an assistant archivist with the archives at NCBS, and I'm very pleased to be welcoming you all to the 62nd edition of the Archive Public Lecture Series. So we at the Archives, we're a public collection center for the history of science, and the history of science in contemporary India. So we also keep track of significant movements happening relatively recently. We house over 100,000 archival objects, papers, photographs, equipment, etc. And as some of you may know, we're located in the basements, in the basement here of the Eastern Lab Complex. We've recently begun expanding this documentation of ecological movements and community-based movements, and now the people's science people. One such example is the Navnirmiti collection that's also housed at the archives, and which you can also see online at the archives website. It's archives.trust.in. I'd like to welcome our speaker today. It's Dr. Prajval Shastri. We invite people who have a vast body of work in service, and how they interact with the work in the context, in the broader social context. So she is an astrophysicist who has a long-standing connection to various institutions in Bangalore. She was faculty at the Indian Institute of Astrophysics for 23 years, and she is currently emeritus scholar at the Raman Research Institute. She has also been a Fulbright Fellow at Stanford University, Senior Associate at TIFR ICTS, and Senior Fellow at the International Center for Radio Astronomy Research, where she is an adjunct professor, which is in Australia. Dr. Shastri is passionate about science outreach and in the cultivation of scientific thinking in the general public, and she has demonstrated the same through her participation in the People's Science Movement and the General Network. She uses astrophysics to engage lay audiences in significant scientific inquiry, and in multiple languages, as you might know from the readings that she sent in Kannada and English. The talk today is titled Growing with Black Holes and with the People's Science Movement. So she is going to acquaint us with her experience into what her experiences of research into black holes and science practice have taught her, in conjunction with the contrasting ethos of her participation in the People's Science Movement, and whether the two may align, and how to best champion scientific thinking. So I leave the mic to our speaker.
Thanks very much, Shravya, and thank you very much for this opportunity. It's a pleasure to talk about a somewhat unusual topic, even for me. I will do the best I can, and I also want to say that I hope there will be questions and interactions later. I encourage you to ask even questions that you might think are quote-unquote personal, because a lot of this kind of work is connected to what normally are called personal beliefs, which interact with how we function, and certainly how I function. And so you can leave it to me to draw the boundaries. I mean, I'm not promising that I'll answer every question, but you can leave it to me to draw the boundaries and ask whatever questions you like. I would like to acknowledge all my collaborators, of course all my colleagues and mentors, my fellow travelers in the People's Science Movement, all of my family and a few more who impel me to think about some of the ideas that I will present today, including Shobha Chatterjee, Komal Srivastava, Vivek Montero, Geeta Mahashabde, M. Parameshwaran, Chanika Shah, Ganesh Devi, and Geeta Chadda. So this is a view of the night sky, unfortunately not a typical view of the night sky anymore, but this picture was taken in the nice dark place of Ladakh. And most of the shiny points of lights that we see when we look at the sky like this are stars. Some of them are planets, but mostly they're stars in our own Milky Way. And this sort of scene is something that the human eye sees, but the human eye is only sensitive to visible light, which is a very, very small sliver of all the kinds of light that is produced by physical phenomena in the cosmos, which is what this graph shows. So the rainbow colors are what the human eye can see, but the cosmos has physical processes that produce radio light right up to X-ray and gamma ray light with a range of frequencies increasing sort of from left to right in this kind of representation. And why should we look at the cosmos in all these frequencies? So this is a picture of Saturn that most of you would be familiar with as taken in visible light, and this is the same thing taken in radio light, and you will say, well, nah, it's not very different. But if you look at Jupiter, this is the visible light image, and that is the radio image, which looks very, very different. And in fact, it's the actual planet Jupiter sits somewhere in between, and this tells us that Jupiter is actually a very, very large and strong magnet, which is something we would never have learned if we only looked at visible light. So that's a motivation why astrophysicists want to look at the cosmos in frequencies beyond what the human eye can see. And so they construct all these telescopes, some of them based on the ground. This is the Venubapu telescope operated by my erstwhile institution. So telescopes operating and sensitive to visible light, that's also visible light. This sensitive to X-ray light, infrared light. This is an Earth-based telescope sensitive to radio light in Maharashtra. And also going beyond light, trying to detect particles called neutrinos and trying to detect ripples in the very fabric that we sit in. And each of these facilities is an enormous engineering feat, and it is with such telescopes that black holes are found. So what are black holes? They are chunks of the fabric in which we sit, which we call space-time, from which even light cannot escape. And we can play a game with the physics that we learned in high school to sort of get an intuitive feel for what black holes are. So you throw something on the surface of the Earth, it comes down to the Earth, you throw it faster, it goes further but still comes down, but if you throw it even faster, it will start to go around the Earth, and there is a speed beyond which it will no longer return or circle but escape from the gravitational pull of the Earth. And for those of you who like formulae, here is the formulae that we learned in high school, which relates the mass from which you're trying to escape and the speed with which the speed that you need in order to escape. And if you imagine, let's say, all the mass of the Earth is squeezed into a smaller size, then you keep the same mass but squeeze it. What happens is that the escape speed now to escape from that squeezed Earth is much higher. So if you continue this thought experiment and squeeze it so much that the escape speed becomes the speed of light, which is 300,000 kilometers a second, then of course you know that nothing can escape. So it turns out that the Earth needs to be squeezed to something like a marble size in order for that to happen. the interesting thing is when you play this game, you get a relationship between the mass that you're trying to escape from and the size. And so this marble-sized Earth would be a black hole. Of course, you would say, but that's impossible. I mean, that's unphysical, and rightly so. But the interesting thing is that if you increase the size of something, so from the Earth you go to the Sun, and then you squeeze the Sun in order to make it into a black hole, then it's less of a squeeze, because the Sun is much, much more massive than the Earth is. And then if you go to Gargantua, which is a fictitious black hole in the film Interstellar, that was given a mass 100 million times the mass of our Sun. So when that was a black hole, it was even less of a squeeze, and that is how the protagonist was able to survive going close to it and entering it and all of that. So the more massive something is, the less of a squeeze it is to make that into a black hole. Now, what happens when some stuff comes near the black hole? Obviously, the gravity of the black hole draws it. It starts to swirl around the black hole before eventually plunging into the black hole. But in the process of swirling, it is accelerated very strongly and to very high temperatures, and so that stuff glows. And because it glows, we are able to see it to very, very large distances, because this glow is extremely powerful. In fact, for something like Gargantua, it is more powerful than the light from all the stars of a galaxy put together. And so they become beacons in the cosmos. We can see them up to very, very early times in the universe. But in order to really understand the physics of black holes, we can't just keep playing this high school game. We have to invoke that different way of understanding gravity, which is over a century old now, thanks to Einstein, who said that gravity is not a force between two things, but is the curvature of space-time itself when there is mass in that space-time. Space-time is just another name for the fabric in which we sit. We call it space-time because space and time are quite a bit intertwined. We know that from our everyday as well, because if I say that I'm here, that's not a complete description, because I'm only here now. I wasn't here yesterday, so I have to say I'm here now. So space and time are intertwined, but they're much more intertwined, as it turns out, than is intuitively obvious. But regardless of that, what Einstein's new way of understanding told us is that every mass, whether it's my mass, your mass, the mass of this book here, or of the Earth, or of the Sun, or the solar system, curves the space-time around them, and higher the mass, larger the curvature. And this is the reason why stuff swirling around black holes looks the way Gargantua looked. Because if you just had an object and stuff swirling around it and that stuff glowed, then you wouldn't see the glow from behind, because this thing is in the way. But if that thing is so massive that it curves space-time, then light has to go along the curvature of space-time, because light has to follow space-time. So then you see the glow from what is behind the black hole. So that glow curves across the black hole and becomes visible to us, and that is why you see this sort of hat-shaped structure. So this is really the glow from the stuff that is behind the black hole, and so is this. And so the interesting thing is that, so this is a picture of our Milky Way, taken from Ladakh again. I have never seen the Milky Way like this, horizon to horizon, until I once went to Australia to observe at the observatory there. And this is what it looked like, actually. So this was something that has been visible and fascinated people for centuries, and it was never suspected until a few decades ago that at the center of our Milky Way would be a giant black hole, very, very similar to Gargantua. So I want to show you the discovery of that black hole. It's my most favorite image ever. But before doing that, I want to explain what we're looking at. So this is a picture again of the Milky Way from the dark. The Milky Way is a big spiral galaxy, as you know, and the center of that galaxy is in this direction, which is very close to this Sagittarius teapot spout. And so what this is showing is a picture of the very, very center, taken in the infrared. Each multicolored splotch is real data of a star at the very center of the Milky Way. And this team, led by Andrea Ghez, used a telescope in Hawaii to image these things starting in 1995 and then continuously imaging them across the decades. All those images put together into an animation show us the positions of these multicolored splotches or the stars, and therefore how the stars move. The cross at the center is not real data, that you will see why that is there. So now I will show you this animation, and the counter of time is there. So the thing starts in 1995, and so you can see the splotches moving, the stars are moving. So obviously the stars, it's obvious from this animation that the stars are not moving in straight lines, they're not moving randomly, they're moving in elliptical orbits, very, very reminiscent of our own planetary system. And all the elliptical orbits have the same focus, namely that cross. So that tells us that there is a very, very massive something there at the position of the cross that is driving all these stars in elliptical orbits, just like the sun drives all the planets in elliptical orbits. But moreover, the very closest one, it has approached very close to that cross, which continues along its elliptical orbit. And so there's no evidence of any collision or deviation from the elliptical orbit, which tells us that that dark thing which is driving all of these in elliptical orbits has to be smaller than that closest separation. So we have an upper limit on the size, we know what is the mass. It turns out that this thing has to have a mass of 4 million solar masses, which means given its size, it has to be a black hole. And it turns out that virtually every galaxy we've looked at has such a giant black hole. And not only does the swirling stuff around it glow, it turns out that this swirling stuff is heated to such high temperatures it becomes plasma, and you have 2 jets of plasma that are launched in the outward direction. So not all the stuff eventually lands up inside the black hole. Some of it is squirted out outside of the galaxy even sometimes into these bipolar jets. And sometimes they even, they're launched so powerfully that they go entirely outside of the galaxy itself, as is seen in this image. Also, galaxies come together due to various gravitational processes. They disturb each other's stellar orbits. We have snapshots of such processes happening. These are real pictures of real galaxies, and simulations tell us that such interactions will result sometimes in eventually the 2 galaxies becoming a third one, and the 2 central black holes coalescing to become a single black hole. This is an example from my own work, a galaxy called the Karaf galaxy, in which we confirmed the existence of these twin black holes in the center. So this disturbed structure that you see is the result of 2 galaxies coming together, have already come together in the past, and then we imaged it in radio light and discovered what are likely baby jets of plasma that are launched from each of these black holes, and we looked at it in X-rays with the Chandra X-ray Observatory and found that indeed there is matter around those black holes that's glowing. So that is to give you a flavor of the kind of research that we do in trying to understand the physics of black holes. So the kind of comments I will make about science practice and about later my experience with the People's Science Movement kind of derive from these various institutional experiences that I've had. So this was St. Agnes College in Mangaluru, where I did my undergrad, and then I went on to do a master's in IIT Bombay and then a PhD in TIFR. So while I was an undergrad student in St. Agnes College, I majored in physics, chemistry and mathematics, and it was a fun place, I have to say. I would say chemistry and maths curricula were pretty good. Physics was not that great, but one thing looking back was very clear was that my teachers were very passionate and very demanding and rigorous, showed no stratification either of disciplines or of stratification between so-called theory and so-called experiment. So it was quite a shock when I went for my master's to IIT Bombay to find that there was this ethos that brilliant people did theory and the not so brilliant people did experiment. In IIT, it was for the first time, thanks to a couple of fabulous teachers, that I realized that it's not only famous physicists who make new discoveries, that regular people like me could also contribute to knowledge creation. This was something that I kind of hadn't realized in college, and it was only in IIT that I learned that. But of course, it was also in IIT that for the first time I saw signs of sexism within an educational space. And then I went on to TIFR to do a PhD, and it only got worse. So then I did postdocs at the University of Texas at Austin, Berkeley, and then Harvard Smithsonian Center for Astrophysics, and then I was faculty in the Indian Institute of Astrophysics for a couple of decades, a short stint in Stanford for sabbatical, ICTS as senior associate, and Raman Institute currently, and also somewhat extended position at ICRAD, which is a relatively new astrophysics center located within the University of Western Australia. So this is the kind of bias that I bring to the comments I make about science practice. I haven't actually been in institutions that whose primary mandate is teaching, for example. So to the People's Science Movement. The People's Science Movement in India has several components, and this is not an exhaustive list, but there are several which have a national character, namely the All India People's Science Network, the Bharat Jnan Vigyan Samiti, the Breakthrough Science Society, and the India March for Science. In Karnataka, there's the Karnataka Rajya Vijnana Parishad and the Karnataka BGBS, which are part of the All India People's Science Network, and there are also other people's science organizations which are not official members of the People's Science Network, such as Tara Mandala, Bangalore Science Collective, and Karnataka Jnana Vijnana Samiti. Breakthrough Science Society is a national organization founded in 1995. I cannot speak in great detail about it. I'm not a member of the Breakthrough Science Society, but I do partner with them and collaborate on various activities. And this is what their stated goals, for example, cultivating scientific and logical faculty of mind, disseminating and popularizing discoveries, in ethical values and social responsibility, fight against the misuse of science, and so on and so forth. But what comes across clearly is this idea of scientific temper, and this is the kind of idea that I will use when I say scientific temper. This is what I mean: the refusal to accept anything without testing and trial, and the capacity to change previous conclusions in the face of new evidence. So, coming to the history of the People's Science Network, which is what I'm most familiar with, there were several predecessor organizations that kind of perhaps laid the foundation for the ethos of the organization. So in 1918, there was something called the Karnataka Vijnana Pracharani Samiti, which I would translate as Karnataka Committee to Spread Science. And they published a magazine called Vijnana. It was a monthly magazine, and that magazine, the articles have been reproduced and reprinted recently. So, you remember, this is very, very early. And the whole idea was, again, to bring science to the people in the local language. So the topics, there's a huge range of topics. So I just randomly scanned one of them. This talks about the comparison between light bulbs of different kinds, and this talks about influenza, and so on. So apparently it ran for 2 years and stopped after that, and so those have been reprinted now in this form. And you can, it's interesting that the date and so on, you know, it's from, it's not the modern date, but the date is stated in a very sort of old style, old calendar. And the Karnataka Rajya Vijnana Parishad, which I mentioned earlier, plus another entity called Udayabhanu Kala Sangha, together decided to publish this. And as justification, they actually quoted one of the Vachanakaras from Karnataka tradition, who says that because the question arises, why would you want to publish science, republish science articles which were published in 1918? I mean, what relevance do they have? And so the justification that they gave was that, you know, the past and the future combine into this moment, and so that is the relevance of publishing something from science. And I also want to say that there is this idea of scientific temper is something that is an import from the West, but at least in the Karnataka tradition that I'm familiar with, I'm not familiar with other traditions across the country, there is a very well-established Vachanakara tradition, which was sort of a counter to the sort of exploitation and oppression and marginalization that people felt at the time due to the Brahminical ethos. And so they very strongly talked against superstition, basically. So this is a poem, Kallanagara Kandare Halenere. So it says that when a snake's figure, a stone figure of a snake, you pour milk on it, but when a real snake appears, you urge people to kill it. And similarly here, it says Lagnakke Vigna Bharadendu Jyotisha Kelu Vidarana. So it says, why do you want to ask Jyotisha in order to have a wedding which is free of obstacles, and then give some examples like why did Veerabhadra's shawl burn and Mahadevi's shoulder slip, etc. So this idea of either countering astrology or superstition, or saying that we have to base our conclusions on our experience, is not at all something new to the Karnataka tradition, at least. So there were these predecessor organizations. In 1948, there was something called the Vijnana Parishad. I think it's an incomplete name. I don't think I got the name completely correct. But this was, I think, based in Mumbai. 1953, there was the Assam Science Society, which was formed. So there were these small organizations which were forming all over the country. And then in 1958, the government of India came up with the Science and Technology Policy, where it said the intense cultivation of science on a large scale has radically altered man's material environment, provided new tools of thought, etc. And so the government decided to foster, promote and sustain the cultivation of science and scientific research, pure, applied and educational. So in 1960, there was the Orissa Vigyan Parishad, started by J.B.S. Haldane. In 62, the Kerala Shastra Sahitya Parishad was founded. In 68, there was this Federation of Indian Literacy and Science, which was in Bombay by mostly a bunch of BRC scientists, as I understood. And then in 1970, Bharat Gaonkar organized a conference to review the science and technology policy. Sorry about the typo. And then he wrote an article in EPW, and these are some excerpts from that article. So he says, the scientific policy resolution presents a declaration of the government's faith in science, etc. It is an admirable document and needs no modification. This was the conclusion of that conference. It has led to considerable advances in building up an infrastructure for science and technology in the country, and we can no longer be called an underdeveloped country in this regard. But he has criticisms, or rather the conference concluded criticisms. The scientists, we continue to be poor as a country, continue to harbor an underdevelopment syndrome, at least our national managers do. And we continue to run the above-mentioned countries, among others, in our never-ending quest of foreign know-how and foreign collaboration. And he says, we are here face to face with a very serious mismatch, the failure of our society to utilize the infrastructure it has built up and to marshal the talents that it has for the challenging tasks that exist. So this was in 1970. A review of the science and technology policy and its impact. So then in 1973, there was the first conference in the Indian Institute of Science of several of these people who were involved in science groups. One of the things I forgot to mention is this Federation of Indian Literacy and Science. One of their core sort of goals was to take quote-unquote science to the people in the regional languages. So they try to persuade people from various states to write in their own regional languages articles on science and publish them. And this business about writing science articles in the regional language seems a seed for multiple levels of People's Science Movement organizations. So in 1978, the second conference was held in CDS in Thiruvananthapuram, and K.N. Raj was the director there. He was an economist, he wasn't a scientist, but he apparently gave very, very strong support to this conference at the time. And this is one of the things he says. I think that most of the things that welfare economists talk about are those that are obvious to all of us, especially the common people, and so on and so forth. And then he invokes Narayana Guru and so on and social transformation in Kerala. And so it's very clear that there is an underpinning philosophy in his support for this second science conference. People's Science Conference, I should say. So in 1978, in Bengaluru, there were these people, Jagalur Lakshman Rao, Badu Ragi and Srimati Hari Prasad, and also Setu Rao, who started this magazine called Bala Vijnana, which was a magazine for children, a science magazine for children, and that was the seed for the Karnataka Rajya Vijnana Parishad to form in 1980. Srimati Hari Prasad is still around in Mysore, very active, quite a workhorse, and continuing to do this kind of work. The third conference again happened in CDS, and the conclusion of that conference was this whole thing about science as activism. So it very strongly articulated the idea that if science has to be for everyone, then perforce it needs to dismantle the barriers to science becoming for everyone. And the barriers are obviously structural and systemic, and so then it becomes incumbent upon us to work for dismantling those barriers. So in 1984, the Bhopal gas disaster and tragedy happened. That was seen as a pitfall of science, but it also triggered a very, very large number of people to accrete around the already existing people science movement. In 1986, a jatha was conceived from 5 corners of India to Bhopal, to the anniversary of Bhopal, 2nd December. I forgot which the 5 corners were, but at least 3 of them are listed here. And a person called Narendra Sehgal was at the helm of the NCSTC, the National Center for Science and Technology Communication, which was a wing of the Department of Science and Technology. And he saw the already crystallized people science movement as the right kind of force to kind of execute his own job of science communication. And so there was full support of NCSTC for this jatha. I was not part of it at the time, but there are people who talk very excitedly about this jatha and how there were busfuls of people, science activists that included scientists, but not all scientists, who went from these 5 corners to Bhopal and stopped at all the cities and towns on the way, and went to schools and did science experiments and did cultural stuff in the evenings like street plays and poetry and all of that. And so it was seen as a very crystallizing moment. And then in 1987, it was the Prajval Shastri Sahitya Parishad's Silver Jubilee. They had a conference in Kannur, and that is where the All India People Science Network was formed. There were 85 participants at that conference from 25 different organizations. And mind you, this was before the time of digital communication and all of that. In fact, even in this Kala Jata, apparently they use ham radios to communicate with each other and with the different national organizations. So the Jata resulted in the All India People Science Network, and that then became the sort of central organization which carried forth both communication and sharing of methods and mechanisms and concerns and all of that across the country. So in 1989, there was a literacy campaign in Ernakulam district, and the hallmark of that campaign was to use everyday experiences for the literacy campaign, and the mechanism was the Kala Jata again. And the Kala Jata mechanism was not just important because of its form of using poetry and street theatres and song and music and songs and dance and all of that, but also because of the content and the messaging, which was very close to people's everyday experience. So that was what was used in order to campaign for literacy. And this was very, very successful, as it was seen. So, but it was also that there were these bureaucrats who were familiar with the activities of the People Science Movement. So there was this person, Anil Bordia, at the helm of the National Literacy Mission, which was formulated at the time by the Government of India. And so the Ernakulam model was immediately taken up by the Government of India, so much so that Anil Bordia, at the helm of this mission, rewrote the document of the National Literacy Mission. The All India People Science Network, on its part, incubated something called the Bharat Jnana Vigyan Samiti for literacy. So there was a distinct shift from this model of each one teach one and the adult literacy centers in villages all over the country, which were already seen as not successful enough because they were just not keeping up with the illiteracy that was still rampant. And also there was a huge disparity in the literacy between men and women. So illiteracy among women was much higher than that of the men. So that spurred a women's movement. So women's mobilization for the literacy campaign, and women's mobilization happened with the Kala Jhatas. In several parts, women were coming out of their homes even for the first time. And so some of the achievements were that, for example, the literacy primers that were made, that were designed with the intervention of the Bharat Jnana Vigyan Samiti, where, for example, in Rajasthan, they found that there were these 5 different languages apart from Hindi, but the literacy primers were only in Hindi. And the literacy primers were being designed in Jaipur and then dished out to the rest of the state. So they intervened to say, no, the literacy primers have to come from the districts. So they persuaded the government to formulate district committees to design the primers, and there were 1 primer in Hindi and 2 primers in the local language, whichever it was, and so on. They had a novel way of not having people learn the whole alphabet, but choosing words with a limited number of alphabets and connections which were related to their everyday. And so it was a very successful campaign. And of course, BGVS, being a product of the All India People Science Network, saw literacy as a stepping stone. Literacy was not an end of itself. It was only a stepping stone to building awareness of scientific thinking, to building livelihoods, and all kinds of other things as well, life skilling. So there was a whole set of women who were skilled in things like gem cutting at the time. There were already women who were working as weavers and so on, and so that power was enhanced. The women realized that even though they were achieving literacy only now, their children needed to go to school. So that was a big movement of putting their children into school. And so the movement helped in these parents, the women as parents, developing awareness on how to hold the schools accountable. And so there were all these different churnings that were happening as a result of the way the literacy campaign was run. So in effect, the literacy movement was a stepping stone to larger societal transformation. So I just wanted to show a quote from Komal Srivastava, who's a All India People Science Network activist from Rajasthan. She says, poor, illiterate, vulnerable women, when given an opportunity to be creatively involved in a process of education, not only mobilize in large numbers, but also change the material conditions in which they find themselves. They're not only able to take advantage of the mechanisms that are in place, but also able to ensure the enforcement of the law through their struggles and persistence. So today, the All India People Science Network has about 800,000 members all across the country. The members is not a sort of fixed thing, because the membership is something that one renews every year. For instance, I pay 10 rupees every year to the Karnataka BGVS for my membership. There are about 40 organizations which are part of the network. In Karnataka, Karnataka Rajya Vigyan Parishad and BGVS Karnataka are members. And so the poster for this talk had an image of these solar goggles, and I thought the best thing to do was to quote the description given by one of the creators of that, Vivek Montero, who just put this message down in our group WhatsApp. Said this was in 1980, created by this Sangatna. Mind you, this was before the People Science movement had crystallized in such an organized fashion. The punch cards were from TFR dustbins, mylar from Chemicoat, which is now closed. Mylar was sourced by Arun Deshpande, who was using it for solar cookers, and we discovered the transmittance properties and so on. And then it talks about Chandita Mukherjee and Anjali Montero. Chandita sadly passed away recently, but was a very active person even in Hyderabad later on. So I won't go into the rest of it, but yeah, that was a very exciting time, and so these goggles hold very, very fond memories for a lot of people from the People Science movement. So Navnirmiti Learning Foundation is one of the organizations of the All India People Science Network, and they specialize in designing self-constructed materials for science experiments, low cost or no cost experiments, so these are just some images from their work. This is very old. This is from the 1999 total solar eclipse, and this was some pamphlets that they made for the 2012 transit of Venus, and that is the actual transit of Venus in Shaniwarwada in Pune. This is another view. And they've devised a fabulous solar projector, which is very easily made using just a small toy ball and a small mirror. And it's very, very effective in terms of all kinds of experiments you can do with the sun. And this is from the partial eclipse in 2020. And this is a telescope that has been made again with low-cost materials. And this is by Adivasi school. This is another such activity. So 2009 was quite a landmark year. So I'm giving examples, I'll give a couple of examples where collaboration between scientific institutes and the People Science movement could be very, very effective in reaching large numbers of audiences in what we are trying to build. And so 2009 was declared by the United Nations as the International Year of Astronomy, celebrating 400 years of Galileo's discoveries. And so the Indian Institute of Astrophysics decided to take that up in a very big way, and designed a program that was called Universalizing the Universe. That's a phrase thanks to Shobha Chatterjee, whom I mentioned earlier. And so the slogan was that the sky is a universal laboratory, there for everyone. And so we managed to have, by collaborating with the People Science movement, with amateur astronomers, and with stakeholders from various disciplines like theatre, poets and writers and so on, we managed to have more than 140 popular level lectures and discussions countrywide in various schools, colleges, a whole range of institutions. We had landmark lectures, we had sky watching parties. She's an Astronomer was another keystone project of this International Year of Astronomy, which tried to look at the question of why there was a gender gap in numbers, whether in science research or in outreach activities or in governance. And so that was also, a lot of that also happened during that international year. Another campaign, again in close collaboration between scientific institutions and the People Science movement, was the Eyes on campaign. This was a comet which showed up in 2013, and we knew it was going to show up maybe a year earlier, so we devised this multi-stakeholder campaign. I had the privilege of leading it, and there were steering committee members from a whole variety of institutions, amateur astronomers, and people from the People Science Network. Of course, I was also in the People Science Network, and the reach was really large. The comet itself was a bit of a damper in the sense it was not as spectacular as we thought it would be, but nevertheless we used that event to ramify and build up a lot of awareness on a variety of topics. We got people to do simple experiments within schools. There were a whole bunch of posters that were created in multiple languages that were used by a very, very large number of people, and so on. This is another example of a collaboration where we took these experiments that were designed by Navnirmiti, 17 very simple experiments, and got Vigyan Prasar to fund making movies out of them. And so there are 17 movies in both Hindi and English, and they are on YouTube, and that was another success. These are some views from March for Science in 2017. It was very big in Bengaluru. Breakthrough Science Society took the lead in organizing this. So it was meant to highlight many things that were going wrong, both in science policy and in media and so on and so forth. Of course, I had some disagreements with kind of the mission statement of March for Science, which had it as its first point that science should get more funding. My disagreement was not with that fact per se, but more with the idea that giving science and the scientific enterprises more funding, we were not going to increase scientific thinking as a way of life. That was sort of my point, and so I felt that they had to change that. But nevertheless, we participated in it. This is another activity that the People's Science Movement has been doing since 2017. 20th August, which was the day that Narendra Davulkar was killed, has been we have been observing it as National Scientific Temper Day. And so all of you know that 28th of February is National Science Day, which celebrates the discovery of Raman, which eventually got him the Nobel Prize. So then why does one need another National Scientific Temper Day? The reason is that on National Science Day, it has come to be that scientific institutions, of course they have open days, they open up the institutions to the public, and children and adults come and so on. But the emphasis is on the accomplishments of science. The emphasis is less on how we know what we know, and even less on what are the pitfalls of science, what should be the critiques of science practice, and any of those things. So therefore it lands up being not about scientific thinking and more about sort of glorifying the accomplishments of science. And so this is the reason why the People's Science Movement felt that we needed this National Scientific Temper Day. And so in Karnataka, about 20 organizations listed here came together to form something called the Karnataka Forum for Scientific Temper. There are several organizations from the People's Science Movement, from the All India People's Science Network, as well as others, including Breakthrough Science Society, and many organizations which are Karnataka specific, such as Miduratva Samsthe and Manava Bandhutva Vedike, and so on and so forth. So we all came together to form this forum and carry out a campaign for scientific temper. And these are some of our posters. So the posters have messaging from a whole range, right from Purave Dashte Nambu, which means as much belief as there is evidence, that is Narendra Davulkar. And there's Bhimarao Ambedkar saying nothing is infallible, nothing is binding forever, everything is subject to inquiry and examination. And then there is also quotes from Gautama Buddha, from Charaka Samhita, and so on and so forth. Lisa Meitner, Rosalind Franklin, so these are some of the posters. This is something that Navnirmiti made for this campaign. So it's a set of 17 very simple scientific experiments that can be done with very, very little equipment. So we try to popularize this during that campaign, and it continues to be a resource. We have it in multiple languages, and it's WhatsAppable and so on. So this was published in Kannada by the Karnataka Rajya Vigyan Parishad. It's open source, and so this has become very popular and has a lot of impact. I even took it to Ethiopia when I visited there for a conference, and they really liked it. India March for Science, Mumbai in particular, organized a webinar in solidarity with the Strike for Black Lives call, and had a series of webinars on invisible hurdles in academic life. And so we looked at gender justice, hurdles that are based on religious identities, on the tyranny of English, and so on and so forth. So one thing that I think is important to understand, which I find often happens, especially among journalists and analysts of both scientific institutions and science practice, is that one should not conflate scientific temper and building awareness about scientific temper with the practice of science, because they're two kind of different things. And it's also important to not conflate the people's science movement organizations with the scientific institutions, because there again there is some overlap, but they're not the same things at all. So as I said before, when scientific institutions and the people's science movement collaborate, there can be very impactful activities. Similarly, when, or maybe more so, when the government collaborates or facilitates activities of the people's science movement, there can be a lot of impact, as we saw in the literacy movement, where there was actual statistically significant increase in especially women's literacy across the country. But there are also major differences, and I've tried to list them here. So scientific practice in science institutions is really for the chosen few, chosen by some means that's justified by ideas of merit and brilliance and talent and so on and so forth. But whatever it is for the chosen few only. Whereas from the people science movement point of view, scientific thinking is for everyone. And the seeking of truth also. In scientific institutions, it's only for the chosen few. It's only the chosen few who have the capacity to use the scientific method for knowledge creation, etc. Whereas seeking the truth in the people science movement and also in other movements is seen as for everybody, whether it is Buddha or the Sharana movement or whatever. Again, scientific thinking is only in the lab in scientific institutions, whereas for the people science movement, scientific thinking is a way of life, and it's sort of a means to social transformation. The commitment to scientific thinking is not even necessary in order to be part of a scientific institution. It's not among our criteria that are used to hire or promote or any of those things. Whereas commitment to scientific thinking and questioning is how people become science activists. So that is another big difference. And in terms of actual people, the community in the people science movement has very, very few scientists. It has some, but very few, a small minority. So, as I said, questioning within scientific practice is only with respect to the narrow problem that one is tackling in research. So, questioning of other things is not really encouraged. I mean, it depends on the institutional culture of the place. I'm sure it's varied, but in my own experience, in the experience of the institutions I've been at, you're supposed to be really good and do your work well. So looking this way and that way and asking questions about things that are beyond one's lab is not encouraged. Whereas in the people science movements, questioning is front and center. So effectively in science practice, there is no moral compass. whereas in the people science movement, moral compass is the bedrock. So there are some interesting sort of things to note. The people science movement embraces open science and adheres to the idea that knowledge is a public good, whereas the science community is still dragging their feet about open science. The anti-superstition bill in Karnataka, for example, was championed not by the scientists, it was championed by the Pragatipara Mathadishara Vedike, which is a progressive group of monastery heads, and also assisted by the people science movement. The Karnataka textbook fiasco, if you remember this from some years ago, that the scientists, including myself, we were completely oblivious to what was going on, and it was the All India Save Education Committee which combed the textbook and found all these bloomers, and then things happened to correct. When people science movement activists do science engagement, it is not only about building awareness, but it is also about being proactive about what are the barriers to building that awareness. What are the systemic and structural barriers? Whereas when scientists do engagement, it's mostly just science communication. And it is mostly sharing the sort of accomplishments of science and the wonder and the excitement, but less about questioning science practice, looking at the pitfalls, why are there pitfalls, and so forth. So I'll stop there and take questions. Yeah, so there are a few scientists, but most of them tend to be teachers, college lecturers, general citizens, bank officers, people from all kinds of backgrounds, but a lot of teachers and from schools and colleges. Yeah.
I guess my curiosity was more like how are they funded, because every work requires some resources, right? So to spend time on that. Yeah.
It's volunteers mostly, and there's a membership. So for example, Karnataka BGVS, I don't know why they have not revised their membership ever since. It's still 10 rupees a year. The Karnataka Rajya Vijnana Parishad, which is the first Karnataka people science organization, that is a more sort of entrenched, shall we say, organization, in the sense that there were people, there was also Narsimaya and so on who were active in it, so they got land and they got a building, so they have a building, and their core enterprise is publication of science books in Kannada. So they are a business also, they sell their books and so on. And so I guess I don't know the sort of, I should know actually, I'm a life member, but I don't know the budgetary sort of situation there. So there they do permit you to become a life member, and there's maybe also annual membership. But there's also government funding for certain projects. But the majority of these are voluntary based, so they are membership based. And they get funding for projects. So for example, like I said, that first Jatha which happened from 5 corners of the country to Bhopal, that was funded by the NCSTC, the DST NCSTC. And then the Comet program campaign that we ran, that was, of course, those of us who are employed in science institutions, we got some funding from our parent institutions also to say travel to give talks and stuff like that. But Vijnan Prasar funded 3 of our national workshops, and then we had a cascading training workshop program, and so the next level of workshops at the district level were then funded by NCSTC. So government does fund, or used to fund, I should say, programs of this kind. Vidyan Prashad is now shut. So that video series was funded by. So for projects, there is funding from the government. The All India People's Science Network, in particular, does not take funds from foreign sources and any kind of corporate sources. So they only take public funds, and then membership. But yeah, I mean, individual members, they have to put in time over and above their regular livelihood, and it's a struggle.
If I may add to that, I would like for you to comment on whether you feel that structure of volunteering versus within science institutes, scientists volunteering, that leads itself to different groups of people, like more diversity of people being those volunteers within the science, like people who are doing science communication within science institutions versus at this community.
Are you asking whether there's a hierarchy?
Hierarchy, but also who constitutes it? Like, are there more in terms of religion, caste, gender, background, different kinds of background? Is it more diverse in the people science movement compared to science?
So in the people science movement, it's more diverse in the participation. But in the leadership, the usual problems, patriarchy, casteism leaching into is there. And that's a matter of debate. There's the sort of literacy movement and the women's movement that I talked about. It led to an organization being incubated called Samata, which is about social justice. But then again, because of its history, most of the people in Samata are women. So there are all these problems are there. But I would say that I find the ethos is devoid of hierarchy. The leadership does lack diversity, but the ethos is devoid of hierarchy, unlike within scientific institutions. So I feel a very, very different climate in the people science movement. There are those of us with PhDs, with jobs or whatever. There are those who are volunteers and who are struggling, but we have a certain camaraderie, or whatever you call it. That building of fraternity has happened. I also sense that across regions. So when we come together for these All India congresses, there's a huge sort of celebration of various cultural aspects, whether it is food or music or whatever. There's also huge emphasis on language. There are also fights. There's an attempt to have all the talks in English and in Hindi, mostly because people from the south mostly understand English and people from the north mostly understand Hindi. But then if that translation is not done well, then there'll be fights and so on. It's all good. I think that's sort of a healthy ethos.
So are you trying to draw a distinction or some way are there similarities also between scientific temper and scientific thinking? Also, you said there's a critique of scientific temper itself, right? Of it being Western and liberal and individualistic, whereas is scientific thinking through people science movement, is it a different kind of a construct?
I wouldn't distinguish between scientific temper and scientific thinking. I don't know what is the distinction. But for both of those, from the people science movement perspective, it's firstly for everybody. And secondly, not just about science. So, for example, we have a song called Yekendu Kiri, like Ask Why. And that song talks about, you ask why does the crow fly but the cat does not. But you also ask why is there poverty and why are people making the atomic bomb. So you ask questions about everything. and you seek answers based on evidence for everything. So this business about it being a Western concept, I mean, I showed some arguments why I don't agree with that. What was your other thing? You said it's individual. So I don't understand that bit. Well, why individual?
In the sense, the idea of liberal itself is individualistic in the sense. The
Liberal
Western
as
idea
in?
of the individual, the rights of an individual, it's more about the individual, right? Or maybe, I don't know, that's how I see it. So is there, with the people science movement, are we then talking about communities of practice?
Yeah, okay, so I haven't heard this thing about communities of practice, but so I don't exactly know what that means. We should talk later because you're the expert on that. But it's definitely about, like I said, acknowledging the barriers, and the barriers are seen as structural. So the barriers to scientific thinking, the barriers to literacy, the barriers to livelihoods, the barriers to the self-reliance, all of these are seen as systemic and structural. Rather than, so there is no question, in the people science movement I've never heard of anybody, or I would never advocate this sort of self-improvement or, that sort of thing. In science there is a lot of that. I mean, the whole gender question, when it is addressed by scientific institutions, is all about fixing the women. There is huge resistance to acknowledging that the barriers are systemic. So that other part I need to talk to you more about exactly what you mean.
Thank you for that really fascinating lecture. What really fascinated was for me was how you trace the regional histories of these people science networks and the fight against the English in some ways. I was also wondering how much does the larger socio-political climate at a particular time influence, for instance, the climate that we are in currently, do these, both scientific institutions and people's science networks, do they have to sort of buck up, do they have to change their structures, systems, do they have to do something else, or do they feel depressed and compromised? What is the kind of reaction they have?
Yeah, so the people science movements, definitely the climate matters, as the examples that I gave showed, and whether it's the National Literacy Mission or some of the public health initiatives which I didn't speak about so much. So this people science movement has these different, shall we say, sectors where we work. So there's science communication, there's education, there's public health, agriculture. These are broadly the sectors. And so it does matter. Socio-political climate absolutely matters because it then determines what public spending is done on. So Vidyan Prasad supported 3 national workshops for us when we did the Comet campaign in 2013. Today Vidyan Prasad is shut down. Vidyan Prasad had a huge database of videos and books and whatnot. That is now, the website is dead. It's not, none of that can be accessed. So there's definitely that. How we react, yeah, we're definitely depressed. I guess the reaction is not to, the reaction is to just continue to the best one can. Keep producing position statements, reacting to policy, building awareness, those kind of things. Within scientific institutions, it's a struggle there as well, because I mean, obviously the social political climate determines how much funding goes into science, and so there's there was a science and technology policy, there was the funding for science, there was a felt need for increase in that funding, but there was also a certain complacence, a lack of accountability, taking for granted the funding for science. Now there is not an increase in demand for accountability, but there is just a sort of, shall we say, not explicit reduction in science, but a very muddy the waters kind of policy. So it's hard. I can't. I think different scientific institutions are reacting differently, trying to walk on eggshells.
I'm sorry, we're kind of running out of time.
I think there was
one
last
last, two last questions.
Thank you for that very illuminating talk. One of the very nice things that came out from what you spoke about was from the people science movement. Clearly, the ethos and the work they do comes from struggles against power hierarchies, asking questions as in rebellion to something that they're being oppressed against. Particularly, the thread you drew from way back in the past where it all began, it brings all that out very nicely. So clearly, that end of things is even now deeply embedded in power struggles and struggles against oppression. However, the practice of science, I suppose, particularly in modern days, the main claim that they might make is that they're in the business of knowledge generation, particularly also now in hyper-specialized days where science is hyper-specialized and so on, and tools and so on. So they are in the business of generating knowledge. They don't have to worry about power inequalities outside in the rest of the world. But knowledge generation is very important, and so this is the only way we know how to do it now.
Yeah.
So what might be the people science movement's response to something like that? How have they been able to respond to the need for having to come up with new knowledge, not just fight against day-to-day, year-to-year oppression?
So are you asking how the people science movement activists generate new knowledge?
Not whether they or how have they. It is just that in this struggle, in these two, when there are two parties, one are the practitioners of science and the other people are just the people science movement, and when they have to square off against each other, let's say, I suppose the practitioners of science will say we are doing knowledge generation, hyper specialized. We don't have to worry. We don't worry about moral compass, things like that. But for the other group, that's all central. But the practitioners of science say through all of this we come up with knowledge.
I think I need to think about what you are asking a little bit. But I don't know of examples where sort of a people science movement has taken on a scientific institution, shall we say. They react, of course, mostly to policy, but of course, if for example, IIT Kharagpur, of all places, they produced a calendar last year, which was not by the science departments, it was by some new department called knowledge science or something. I forget the name, whatever. But they produced a calendar which was simply unacceptable. It wouldn't pass muster with any kind of scrutiny, and they still produced it and they propagated it. So then, of course, the People's Science Movement responded to that, saying, with all the criticisms. But so that is maybe one example where they take them on, but not in general of this overall ethos of being not accountable or not having a moral compass, or they don't take science institutions on like that. least I don't know of examples. They did, for example, in which year was it? I now forget, but in before 2005, in that term of government, astrology was made as a subject in universities. So at that time, a lot of the scientists also protested against that. And definitely the People Science Movement people protested. But then that was more of a protest against policy again, not so much a protest against the institutions per se. So I don't know of examples where they're directly taken on institutions, except maybe this calendar one. I don't know if I answered your question, but
I just wanted to draw the link in the comparison that you made of the practice of science and the people science movements. You had said two things. First, you said that both say that they are searching for the truth, but one of them is also searching for the truth in a broader sense of, the way Gautam Buddha searched for the truth, or Ambedkar is searching for the truth, and so on. And then the point about the moral compass, and I think the two are in a sense related, right? Because the word truth is being used differently in the two parts or the two columns. And especially the way you have defined it, it might be because of the narrow definition that you use, because when we say that the practice of science doesn't have a moral compass, it is only the practice of physical and biological sciences that doesn't have a moral compass. The practice of social science has a moral compass. If social science is a science, then it has a moral compass, usually hidden, explicit, mixed, confused, whatever. And sometimes social science is also confused about whether it is a science itself or not. And sociology textbooks start with the chapter which says, is sociology a science? So they have gone into some other loop. But so part of the problem of why Satya for one is all truth and Satya for the others is only a narrow truth about the biophysical world, not about the human world, not about the social world, is partly because of the academic fragmentation between natural and social sciences, and then confusion about what Satya is.
yeah, maybe that's true. I don't know. But I mean, social sciences also, they claim that they are objective and distant from their subject and so on, right? So for instance, anthropology studied, at one time anthropology looked at, the global south with binoculars. There was no moral compass. I don't know, I have to think about this.
Perhaps the difference between science that's sanctioned by local parliament and
Sorry, sanctioned by?
perhaps it's a question of what science is sanctioned by those in power and what is not.
Huh.
So maybe that's the narrow. Anyway, so we can continue these conversations outside, where I hope there is TV and space. And also, Dr. Shastri agreed to, she would like to stay back and continue conversations over dinner as well, so she'll be available in the main canteen. So, thank you so much for attending the APLS, and thank you to Instrumentation and